Picture this. Every time you glance at your phone, look in a mirror, or simply observe the world around you, you might be fundamentally influencing how reality is experienced. Not metaphorically, not philosophically, but at the deepest level of existence, where the very fabric of the universe appears to respond to the simple act of observation. This isn't science fiction, this is quantum mechanics, and it suggests something extraordinary about your role in participating in the world you experience every single moment. Welcome back to another journey through the mysteries that surround us. I'm here to explore with you one of the most profound and unsettling discoveries in modern physics, the observer effect, a phenomenon so strange that it has forced scientists to question everything they thought they knew about reality, measurement, and the fundamental nature of existence itself. Today, we're going to drift gently through this mystery together. We'll discover how a simple physics experiment revealed that observation isn't passive, how the universe can appear to exist in multiple states until something, or someone, decides to look, and why this discovery has sparked decades of debate about whether consciousness could play a fundamental role in determining what becomes real. As we begin this exploration, let me invite you to settle in. Get comfortable. This isn't a race through complex equations or a frantic tour of scientific jargon. This is a slow, contemplative journey into one of the deepest questions we can ask. What is real? And do we in some sense participate in shaping it simply by looking? The story begins in a place you might not expect, not in some grand laboratory or university lecture hall, but in the simple act of measurement itself. Something so basic, so fundamental, that we rarely stop to think about what it actually means to observe something. Yet this innocent act, this simple looking, has revealed secrets about the universe that continue to challenge our most basic assumptions about reality. In the early 20th century, physicists believed they understood the world quite well. Matter was made of particles. Energy travelled in waves. Objects had definite positions, definite velocities, and definite properties whether anyone was looking or not. The universe was like a vast clockwork mechanism, predictable and orderly, where every effect had a clear cause and observation was merely a passive act of discovery. Then came quantum mechanics, and everything changed. The first hints of something strange emerged when scientists began studying light itself. They discovered that light could behave like a wave, spreading out and creating interference patterns, or like a stream of particles, depending on how they chose to observe it. This wave-particle duality was puzzling enough, but it was just the beginning. The real shock came when researchers realized that this strange behavior wasn't limited to light. Electrons, atoms, and even molecules could exist in what scientists call superposition. Multiple states simultaneously. An electron could be spinning clockwise and counterclockwise at the same time. A particle could be in two places at once. The quantum world seemed to operate by rules that defied common sense. But here's where it gets truly mysterious. These quantum superpositions only persist until someone tries to measure them. The moment a detector is placed, the moment an observation is made, the superposition appears to collapse. The particle settles into one state or the other, as if the universe itself had been waiting for an interaction to become definite. This phenomenon became known as the observer effect, and it has been confirmed in thousands of experiments over nearly a century. Every time scientists try to catch quantum particles in their natural, undisturbed state, the very act of looking changes the outcome they observe. Take a moment to consider what this means. In our everyday experience, observation is passive. When you look at a tree, you don't expect the tree to suddenly change because you're watching it. When you check the time on your clock, the clock doesn't rearrange its numbers based on your attention. But in the quantum realm, observation functions as an active part of the measurement process. The implications are staggering. If the fundamental building blocks of reality exist in multiple states until observed, what does this say about the nature of the reality we experience? Are we passive witnesses to an objective universe, or are we participants in how outcomes become defined? To understand just how profound this mystery is, let's journey to one of the most famous experiments in physics, the double-slit experiment. It's beautifully simple in its setup, yet revolutionary in its implications. Imagine a barrier with two narrow slits cut into it. Behind this barrier, there's a screen that can detect where particles land. When you fire a stream of particles, say electrons, at this barrier, some pass through the left slit, some through the right, and they create a pattern on the detection screen. If electrons were simply tiny balls, you'd expect to see two bands of impact on the screen, corresponding to the two slits. But that's not what happens. Instead, the electrons create an interference pattern. Multiple bands of impacts, with some areas where no electrons land at all. This pattern can only be explained if each electron behaves as though it passes through both slits, interfering with itself like a wave. The natural question becomes, which slit does each individual electron actually go through? So scientists set up detectors at each slit to find out. And this is where the mystery deepens. When detectors are placed to observe which slit each electron passes through, something remarkable happens. The interference pattern disappears. Suddenly, the electrons behave like particles again, going through one slit or the other, creating just two bands on the screen instead of the wave-like interference pattern. The electrons appear to respond to the presence of measurement. When no information is gathered, they act like waves, exploring multiple paths simultaneously. When path information is obtained, they behave like particles, taking definite paths through definite slits. This isn't a story about technology being too crude or measurements being too disruptive. Modern versions of this experiment use the most sophisticated detection methods available, and the results remain the same. The simple presence of information about the electron's path is enough to change its behavior fundamentally. As you contemplate this, notice how it might challenge your own assumptions about reality. We're accustomed to thinking that things have definite properties independent of our knowledge of them. Your car is either in your garage or it isn't, regardless of whether you check. But quantum mechanics suggests that at the fundamental level, reality might be far more fluid than we imagine. The double-slit experiment reveals something profound about the relationship between observation and existence. It suggests that at the quantum level, particles don't have definite properties until those properties are measured. They exist in what physicists call superposition, a ghostly combination of all possible states, until the moment of observation results in a single, definite outcome. This discovery has led to what physicists call the measurement problem. If quantum particles exist in superposition until measured, what exactly constitutes a measurement? What transforms the quantum realm of possibilities into the classical realm of definite outcomes? The question seems simple, but it has puzzled physicists for nearly a century. Does a measurement require a conscious observer? Is there something special about awareness itself? Or is any interaction with the environment enough to produce the collapse of the quantum superposition? Some interpretations of quantum mechanics suggest that consciousness may play a fundamental role. In this view, the universe exists in a state of pure potential, until a conscious observer makes a measurement, at which point reality appears to crystallize into the specific outcome that is observed. This interpretation, while historically significant, has largely fallen out of favor among mainstream physicists, though it continues to intrigue philosophers and some researchers. Most modern physicists favor explanations based on environmental decoherence. In this view, quantum systems lose their superposition not because of consciousness, but because they inevitably interact with their environment. Every quantum particle is constantly bombarded by photons, air molecules, and other particles. These interactions entangle the quantum system with its surroundings, effectively destroying the delicate superposition and forcing the system into a definite state. This process happens almost instantaneously for large objects in everyday environments. A grain of sand, for instance, would lose its quantum coherence in a fraction of a second due to interactions with air molecules and thermal radiation. This is why we don't see superpositions of everyday objects. By the time we can observe them, they've already been forced into definite states by their environment. Yet even this explanation leaves questions unanswered. If everything is ultimately made of quantum particles, and those particles exist in superposition until measured, how does the classical world of definite outcomes ever emerge? This boundary between the quantum and classical realms remains one of the deepest mysteries in physics. Consider your own experience right now. As you listen to these words, countless quantum events are occurring in your brain, in the air around you, in the screen you might be looking at. Yet your experience feels decidedly classical. You have a definite sense of where you are, what you're thinking, what you're feeling. The quantum fuzziness that underlies everything seems to resolve into the crisp reality of conscious experience. This tension between quantum possibilities and classical certainties was famously illustrated by physicist Schrodinger through a thought experiment involving a cat. Schrodinger imagined a cat placed in a sealed box with a Geiger counter, a radioactive atom, and a mechanism that would release poison if the atom decayed. According to quantum mechanics, the radioactive atom exists in a superposition of decayed and not decayed states until observed. Following this logic, Schrodinger argued that the cat would also exist in a superposition of alive and dead states until someone opened the box to look. This seemed absurd. Cats are either alive or dead, not both simultaneously. Yet if quantum mechanics applies to everything, this impossible situation should be possible. Schrodinger created this thought experiment not to support the idea of quantum superposition in large systems, but to highlight what he saw as an absurd conclusion of quantum theory. He believed it revealed something incomplete or incorrect about the standard interpretation of quantum mechanics. Yet experiments continue to confirm that quantum superposition is real, at least for microscopic systems. Scientists have demonstrated superposition in increasingly large and complex systems, from individual atoms to molecules containing hundreds of atoms. While no one has yet created a superposition of something as large as a cat, the boundary between the quantum and classical worlds continues to be pushed further than many thought possible. The cat paradox illuminates a fundamental question about the role of observation in quantum mechanics. Does the cat state become definite only when a human opens the box? Or is the cat itself an observer, capable of triggering the collapse of its own quantum state? What about the Geiger counter or the poison mechanism? Where exactly does observation begin and end? These questions aren't merely academic. They point to deep uncertainties about the nature of consciousness, measurement, and reality itself. They suggest that the simple act of looking might be far more profound than we ever imagined. Breathe for a moment and consider this possibility. Every observation you make, every glance, every measurement might be participating in the creation of reality itself. Not in some mystical or unscientific way, but through mechanisms that physics is still struggling to understand. The universe might be far more participatory, far more responsive to awareness than our classical intuitions suggest. While quantum effects are most obvious at microscopic scales, they're not confined to laboratories and theoretical physics. Quantum mechanics underlies many technologies you use every day. The computer or phone you might be using to access this content relies on quantum effects in its semiconductors. Lasers, which enable fiber optic communications and countless other technologies, operate on quantum principles. Even the GPS system in your car requires corrections for quantum effects to maintain its accuracy. More fundamentally, quantum mechanics governs the chemical bonds that hold matter together, the nuclear reactions that power the sun, and the biological processes that sustain life. In a very real sense, you're a quantum being, composed of quantum particles following quantum rules, even though your macroscopic experience feels thoroughly classical. This raises profound questions about the relationship between levels of reality. If your consciousness emerges from quantum processes in your brain, and those processes exist in superposition until observed, what does this mean for the nature of your thoughts, your decisions, your sense of self? While we must be careful not to make unsupported claims about consciousness directly influencing quantum events, the connection between mind and quantum mechanics remains an area of active philosophical and scientific exploration. Some researchers have proposed that quantum effects might play a role in biological processes like photosynthesis, bird navigation, and even consciousness itself. While these ideas remain speculative and controversial, they hint at the possibility that life has found ways to harness quantum effects that we're only beginning to understand. The observer effect might be more than just an interesting feature of physics experiments. It might be a fundamental aspect of how reality operates at every level, from the smallest particles to the largest structures in the universe. The simple act of observation, of measurement, of attention itself might be woven into the very fabric of existence. As we continue this exploration, we'll delve deeper into these mysteries. We'll examine the various interpretations that physicists have proposed to explain the observer effect. We'll look at cutting-edge experiments that push the boundaries of our understanding, and we'll consider what all of this might mean for your own relationship with reality. But for now, let this idea settle gently into your awareness. You are not merely a passive observer of the universe. Through the simple act of observation, you may be participating in the ongoing creation of reality itself. Every moment, every glance, every conscious awareness might be contributing to how reality is experienced. The observer effect invites us to reconsider our place in the cosmos. Rather than being separate from the world we observe, we might be intimately connected to it in ways that physics is still learning to describe. The boundary between observer and observed, between mind and matter, between consciousness and cosmos, might be far more fluid than we ever dared imagine. This is just the beginning of our journey into this mystery. There are deeper questions ahead, stranger experiments to explore, and more profound implications to consider. The observer effect opens a doorway into a universe far more mysterious, far more participatory than our everyday experience suggests. And as you continue listening, as you continue observing, remember that you are not just learning about reality. In some sense, through the very act of conscious attention, you might be helping to shape how it unfolds. As we drift deeper into this mystery, we encounter one of the most radical proposals in modern physics. What if the observer effect doesn't actually cause anything to collapse at all? What if instead, every possible outcome of every quantum measurement actually occurs, but in separate parallel realities? This is the essence of the many worlds interpretation, proposed by physicist Hugh Everett in 1957. According to this view, when you observe a quantum particle that could be spinning clockwise or counterclockwise, both outcomes are described as occurring within the framework of the theory. The universe is said to branch. In one branch, you observe clockwise spin. In another branch, a corresponding version of you observes counterclockwise spin. Both versions of you are treated as equally real within the model, but forever separated by the branching of reality itself. Take a moment to contemplate this possibility. Every quantum measurement, every observation, every moment of uncertainty resolved could be associated with countless new worlds. When you flip a coin, both heads and tails are represented, but in different realities. When you make a decision, all possible choices are mathematically realized across parallel universes. The you that chose one path continues in this reality, while other versions of you are described as exploring different possibilities in realms you'll never know. This interpretation eliminates the need for wave function collapse entirely. The quantum superposition never disappears. Instead, it is understood to expand to encompass all possible realities. The observer effect becomes not about collapsing possibilities into a single outcome, but about determining which branch of the infinite tree of realities you find yourself experiencing. Some physicists find this interpretation elegant because it preserves the mathematical purity of quantum mechanics without requiring arbitrary collapse postulates. Others find it troubling because it implies the existence of an infinite number of theoretically unobservable parallel worlds. The multiverse becomes not just a scientific theory, but a conceptual framework, with new worlds described as branching from every quantum event, every observation, every moment of your existence. Consider what this might mean as you go about your day. That moment when you glanced at your phone earlier today could be framed as reality branching into paths where you looked and paths where you didn't. The quantum processes in your brain, the photons hitting your retina, the electrons flowing through the device, all potentially corresponding to countless parallel versions of this moment across an infinite array of worlds. Yet even if this interpretation is correct, it doesn't diminish the profound nature of your role as an observer. In each world, in each branch of reality, observation still determines what becomes definite for the consciousness experiencing that particular reality. You may not be collapsing the wave function for the entire universe, but you may be identifying which slice of the infinite multiverse becomes your experienced reality. As we explore these ideas, it becomes clear that the observer effect might be fundamentally about information rather than consciousness or measurement devices. Modern physics increasingly recognizes information as a basic feature of reality, perhaps as fundamental as matter and energy themselves. When a quantum system exists in superposition, it carries a specific amount of quantum information. This information describes all the possible states the system could be found in and their relative probabilities. The moment an observation extracts information from this system, something profound happens. The quantum information is transferred from the observed system to the observer, whether that observer is a conscious being, a detector, or simply the environment. This transfer of information appears to be what drives the transition from quantum possibilities to classical certainties. It's not necessarily about consciousness collapsing wave functions through some mystical process. Instead, it's about the fundamental role that information plays in determining the structure of reality itself. Think about your own experience of observation. When you look at something, you're not just passively receiving light, you're extracting information from your environment. Your brain processes this information, creates models of what you're observing, and integrates it with your ongoing stream of consciousness. In some interpretations of quantum mechanics, this information processing may be more central to reality than we ever imagined. The quantum realm appears to be built from relationships between systems rather than from isolated objects with definite properties. An electron doesn't simply have a position or momentum. Instead, it has relationships with other systems that can potentially extract position or momentum information from it. These relationships, these possibilities for information exchange, might be what we're really observing when we study quantum mechanics. This perspective suggests that observation is fundamentally about creating relationships. When you observe something, you're establishing an informational connection with it. You're becoming entangled with it in the technical quantum sense. Your measurement apparatus, your consciousness, your entire being becomes correlated with the system you're observing. This brings us to another remarkable feature of quantum mechanics that deepens the mystery of observation: quantum entanglement. When particles become entangled, they share a quantum state that persists even when the particles are separated by vast distances. Measuring one particle instantly affects the states of its entangled partner, regardless of the space between them. Einstein famously called this spooky action at a distance and believed it revealed something incomplete about quantum theory. But decades of experiments have confirmed that entanglement is real. The universe appears to be fundamentally non-local. Information can be correlated across arbitrary distances through quantum correlations. Now consider what this means for observation itself. When you observe a quantum system, you don't just extract information from it, you enter into a quantum correlation with it. Your measurement apparatus, and by extension, you as an observer, develops quantum correlations with the system being observed. The act of observation creates a web of entanglement that connects you to the quantum realm in ways that classical physics never anticipated. This entanglement might persist even after the observation is complete. In some sense, every observation you've ever made could have left you quantum mechanically correlated with the systems you've observed. You carry traces of every photon that has ever hit your eyes, every quantum interaction that has ever occurred in your brain, every measurement that has ever registered in your consciousness. The implications are profound. Rather than being separate from the world you observe, quantum mechanics suggests you are intimately and continuously connected to it through webs of entanglement that span space and time. Your past observations may have woven you into the fabric of reality in ways that transcend classical notions of separation and independence. As you reflect on this possibility, notice how it might shift your sense of relationship with the world around you. The light from distant stars that reaches your eyes has travelled for years or centuries, carrying quantum information across vast expanses of space. When that light interacts with the quantum systems in your retina and brain, it establishes correlations that connect you directly to those distant stellar fires. The mystery of observation deepens even further when we consider experiments that seem to violate our basic notions of causality. In delayed choice experiments, the decision of whether or not to observe a quantum system is made after the system has already passed through the experimental apparatus. Imagine sending a photon through a double-slit setup, but delaying the decision of whether to measure which slit it goes through until after it has already passed the slits. According to our classical intuitions, this shouldn't matter. The photon should have already committed to going through one slit or the other by the time it reaches the detection screen. But quantum mechanics tells a different story. The delayed choice of whether to observe the photon's path appears to influence how its behavior is described throughout its entire journey through the apparatus. If you choose to measure which slit it went through, it is described as having behaved like a particle all along. If you choose not to measure, it is described as having behaved like a wave. This suggests that observation might not be bound by the linear flow of time in the way we typically imagine. The future decision to observe might be correlated with the past description of events, not in the sense of changing the past, but in the sense of determining how the past is reconstructed within the experimental framework. This interpretation remains highly speculative and controversial, but it hints at the possibility that the relationship between observation and reality might be even stranger than we've discussed so far. The observer effect might not just be about the present moment of measurement, but about the entire temporal context in which observation occurs. Consider what this might mean for your own experience. The observations you choose to make in the future could influence how aspects of your present reality are understood. The questions you decide to ask, the measurements you decide to perform, the attention you decide to pay might all play a role in determining not just what you discover, but what becomes meaningful to discover. Another fascinating aspect of observation in quantum mechanics is the quantum Zeno effect, named after the ancient Greek philosopher who proposed various paradoxes about motion and time. This effect occurs when frequent observations of a quantum system actually prevent it from evolving. Normally, quantum systems evolve continuously according to the Schrodinger equation, transitioning from one state to another over time. But if you observe the system frequently enough, the repeated measurements keep forcing it back into its original state, effectively freezing its evolution. It's as if the universe respects the old saying about watched pots never boiling. By watching a quantum system too closely, you can prevent it from changing at all. The very act of observation, repeated frequently enough, becomes a kind of temporal anchor that holds reality in place. This effect has been demonstrated experimentally with various quantum systems. It reveals yet another way in which observation plays an active role in determining the behavior of quantum systems. Not only does observation determine what properties a system has when measured, but the frequency of observation can determine whether the system is allowed to evolve at all. Think about the implications for consciousness and attention. If awareness is conceptually linked to quantum measurement processes, then the focus of your attention might be doing more than just selecting which aspects of reality you notice. It might be associated with which aspects of reality are allowed to change and develop. This remains highly speculative, but it opens intriguing questions about the role of attention in shaping experience. The things you pay attention to, the aspects of reality you choose to observe repeatedly, might become more stable and persistent in your experience through something analogous to the quantum Zeno effect. While these exotic interpretations capture our imagination, it's important to return to the more mainstream explanation for the observer effect: environmental decoherence. This process provides a more mundane but equally profound understanding of how observation works. Every quantum system exists in a web of interactions with its environment. Photons from thermal radiation, molecules in the air, electromagnetic fields, gravitational influences, all of these constantly interact with quantum systems and gradually extract information from them. This environmental monitoring effectively performs countless microscopic measurements, forcing quantum systems into definite states without requiring any conscious observer. For macroscopic objects, this decoherence happens almost instantaneously. The quantum superpositions that might theoretically exist for large objects are destroyed so quickly by environmental interactions that they never have a chance to manifest in observable ways. This is why you don't see cats in superposition or tables existing in multiple locations simultaneously. But decoherence doesn't eliminate the mystery of observation entirely. It simply pushes the question to a deeper level. If environmental interactions can collapse quantum superpositions, then what makes the environment itself have definite properties? At some level, the buck has to stop somewhere. Something has to determine what becomes real and what remains mere possibility. Some interpretations suggest that consciousness could play a role in determining which environmental interactions count as measurements and which don't. Others propose that the distinction between quantum and classical behaviour emerges naturally from the mathematics of many-body quantum systems without requiring any special role for consciousness or observation. The debate continues, but what remains clear is that observation, whether conscious or environmental, plays a fundamental role in determining the structure of reality. The universe appears to be constructed in such a way that information extraction, relationship formation, and attention all participate in the ongoing process of determining what exists. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. As we weave together these various threads, a picture emerges of observation as a fundamentally creative act. Rather than simply discovering pre-existing properties of reality, observation appears to participate in determining what reality becomes. This doesn't mean that consciousness creates reality in some magical sense, but it does suggest that the relationship between observer and observed is far more intimate than classical physics ever imagined. Every time you observe something, you're not just learning about the world, you're participating in the ongoing process by which the world becomes definite, through the extraction of information, the formation of quantum correlations, the focus of attention, and the simple act of looking. You become an active participant in the unfolding of reality itself. This participation happens at every scale. The quantum processes in your brain that give rise to consciousness, the interactions between light and the receptors in your eyes, the environmental decoherence that makes the macroscopic world appear classical. All of these work together to create the seamless experience of observing a definite, objective reality. Yet beneath this seamless experience lies a more fluid, participatory universe where observation and existence are intimately intertwined. The classical divide between subject and object, between observer and observed, begins to dissolve when we take quantum mechanics seriously. Consider how this might influence your daily experience. Every moment of awareness, every conscious observation, every choice about where to direct your attention might be participating in this vast, ongoing creative process. Not through mystical influence over quantum events, but through the fundamental role that information and relationship play in determining the structure of reality. The observer effect invites us to see ourselves not as passive witnesses to an independent universe, but as active participants in a cosmos that is continuously becoming itself through the interplay of observation, measurement, and conscious awareness. We are not separate from the reality we observe. We are woven into its very fabric through quantum correlations, informational relationships, and the simple but profound act of paying attention. This perspective doesn't diminish the objective nature of scientific knowledge. It doesn't mean that reality is merely subjective, or that you can think your way into changing the laws of physics. Instead, it reveals a universe that is more relational, more participatory, more responsive to the presence of observers than our classical intuitions would suggest. As we continue to explore these ideas, we'll delve even deeper into the implications of this participatory universe. We'll examine how modern experiments are pushing the boundaries of what we know about observation and reality. We'll consider what this might mean for consciousness, free will, and the nature of existence itself. But for now, rest in this possibility. You are not merely a spectator in the cosmic drama. Through the simple act of conscious observation, you are participating in the story of what becomes real. Every moment, every glance, every conscious choice about where to direct your attention takes part in the ongoing creation of the universe itself. The observer effect reveals a cosmos that is alive with possibility, responsive to observation, and fundamentally participatory in nature. And you, as a conscious being capable of observation, are an integral part of this magnificent, mysterious, ever-unfolding reality, folding reality. As we drift deeper into this quantum mystery, we encounter one of the most mind-bending thought experiments ever conceived. It's called Wigner's friend, and it reveals something unsettling about the nature of observation itself. Something that suggests the observer effect might create an infinite regress of realities, each nested within the other like Russian dolls made of pure possibility. Picture this scenario. A physicist named Wigner has a friend working in a laboratory. The friend performs a quantum measurement on a particle that could be in one of two states. From the friend's perspective, the moment she makes the measurement, the particle's wave function collapses into a definite state. Let's say she observes the particle spinning clockwise, but here's where it gets strange. From Wigner's perspective, looking at the laboratory from the outside, the entire system, including his friend and the particle, remains in quantum superposition until he himself makes an observation. According to the mathematics of quantum mechanics, the friend exists in a superposition of having measured clockwise spin and having measured counterclockwise spin. Both perspectives seem equally valid. The friend insists that she observed a definite result. Wigner maintains that no definite result exists until he observes the laboratory. They cannot both be right, yet quantum mechanics seems to support both viewpoints simultaneously. This paradox reveals a fundamental problem with the idea that observation collapses quantum superpositions. If consciousness or measurement devices can collapse wave functions, then who or what gets to be the ultimate observer? Where does the chain of observation end? Each observer seems to push the moment of collapse further up the chain, creating an infinite regress where no final collapse ever occurs. Consider how this might apply to your own experience right now. As you listen to these words, quantum processes are occurring in your brain, in the air around you, in the device delivering this content. From your perspective, these processes have definite outcomes that create your coherent experience of consciousness. but from the perspective of a hypothetical external observer within certain interpretations, you and your entire environment could be mathematically described as existing in quantum superposition until that observer chooses to look. This isn't just an abstract philosophical problem. Recent experiments have actually tested versions of Wigner's friend scenario using quantum systems as proxies for conscious observers. The results confirm that different observers can indeed assign different quantum states to the same system, suggesting that a single observer-independent description of reality may not always apply in the way we typically imagine. Take a moment to breathe and consider what this means. The universe might not have a single, definite state that all observers would agree upon. Instead, reality may be fundamentally perspectival, with each observer experiencing their own valid but potentially incompatible version of what exists. This doesn't mean that science becomes impossible or that all observations are equally valid. The mathematics of quantum mechanics still provides precise predictions about what any given observer will experience, but it does suggest that the concept of objective reality, independent of all observers, may need to be reconsidered in light of quantum mechanics. The plot thickens even further when we examine experiments that seem to erase information retroactively. In quantum eraser experiments, scientists first create a situation where they could potentially know which path a particle takes through a double-slit apparatus. This potential knowledge destroys the interference pattern, forcing the particle to behave like a classical object rather than a quantum wave. But then, in a twist that appears to challenge our basic notions of causality, the experimenters erase the path information after the particle has already been detected. They make it impossible to determine which slit the particle went through, even in principle. And remarkably, when they do this, the interference pattern returns. The particle is described as behaving as though it had anticipated that its path information would be erased. It behaves like a wave throughout the entire experiment, even though the decision to erase the path information is made after the particle has already hit the detection screen. The future decision to erase information appears to influence how the particle's past behaviour is reconstructed within the experiment. This suggests something profound about the relationship between information and reality. It's not just that observation affects quantum systems in the present moment. The potential for future information extraction, or erasure, seems to be correlated with how quantum systems behave across their entire history. These experiments push the boundaries of our understanding of time, causality, and the role of information in determining reality. They suggest that the observer effect might not be confined to the moment of observation, but might extend across time, creating a web of correlations that transcends classical intuitions about temporal sequence. As you contemplate this possibility, notice how it might shift your understanding of your own choices and observations. The decisions you make about what to pay attention to, what information to seek, what questions to ask, might not only affect your present experience, but could shape the interpretive context in which that experience unfolds. This remains highly speculative, and most physicists interpret these experiments in terms of correlations rather than backwards in time causation. But they do reveal the deeply mysterious nature of information in quantum mechanics and the profound ways in which observation and reality are intertwined. One of the most challenging aspects of understanding the observer effect is that it forces us beyond binary thinking. In classical physics, things are either observed or not observed, measured or not measured, real or not real, but quantum mechanics reveals a more nuanced landscape where observation exists on a spectrum rather than as a simple yes or no proposition. Partial measurements can extract some information from a quantum system without completely destroying its superposition. Weak measurements can probe quantum properties so gently that they barely disturb the system being observed. Quantum non-demolition measurements can extract information about certain properties while leaving other aspects of the system's quantum state intact. These techniques reveal that observation is not a single, monolithic process, but rather a rich spectrum of possible interactions between observers and quantum systems. Each type of observation extracts different amounts and kinds of information, leading to different degrees of wave function collapse and different transitions from quantum to classical behavior. This spectrum of observation might extend into everyday experience as well. The quality of attention you bring to different aspects of your environment might correspond to different modes of information processing occurring in your brain and sensory systems. Focused attention, peripheral awareness, unconscious processing, and various states of consciousness might all represent different points along the spectrum of observation. Consider how your own attention works as you listen to these ideas. Sometimes your focus is sharp and directed, extracting precise information from specific concepts. Other times, your awareness is more diffuse, taking in the overall flow and feeling of the content without analysing individual details. These different modes of attention may correspond to different informational processes occurring in your neural systems. This perspective suggests that consciousness itself might be understood as a sophisticated information processing system that operates through various forms of quantum measurement. Not in the sense that conscious intention directly controls quantum events, but in the sense that the biological mechanisms underlying consciousness may naturally implement the kinds of information extraction processes that quantum mechanics describes. While we've explored exotic interpretations and strange experiments, it's important to ground our understanding in the more mundane but equally profound process of environmental decoherence. This mechanism explains how the quantum realm of possibilities gives way to the classical realm of everyday experience. Every moment, your body exchanges vast amounts of information with the environment around you. Photons bounce off your skin, air molecules collide with your surface, heat radiates from your body, electromagnetic fields fluctuate around you. Each of these interactions constitutes a microscopic measurement that extracts quantum information from your biological systems. This constant environmental monitoring forces the quantum systems in your body into definite classical states. Your neurons fire or don't fire. Your muscles contract or relax. Your sensory receptors respond to stimuli or remain quiet. The fuzzy quantum superpositions that might theoretically exist in these biological systems are constantly being suppressed by environmental decoherence. Yet this decoherence process is not random or chaotic. Evolution has shaped biological systems to harness environmental decoherence in sophisticated ways. Your sensory systems, for instance, appear to be exquisitely tuned to extract specific types of quantum information from the environment while remaining robust against unwanted decoherence effects. Your eyes can detect individual photons under optimal conditions, operating at the very boundary between the quantum and classical realms. Your sense of smell has been hypothesized by some researchers to involve quantum tunneling effects that help discriminate between different molecular structures. Some researchers even speculate that quantum effects in microtubules within neurons might play a role in consciousness itself. Though this remains highly controversial, The point is not that consciousness directly controls quantum effects, but rather that the biological mechanisms underlying consciousness have evolved to operate in the quantum realm in sophisticated ways. Your brain is not separate from the quantum universe. It is a quantum system that has learned to navigate quantum reality through billions of years of evolutionary refinement. As you reflect on this, notice how it might change your relationship with the physical world around you. You are not merely a classical object observing a classical environment. You are a quantum system embedded in a quantum environment, constantly exchanging information, forming correlations, and participating in the ongoing dance between possibility and actuality that defines quantum reality. Modern physics increasingly recognizes information as a fundamental feature of reality, potentially as basic as matter and energy themselves. This perspective, known as it from bit in the words of physicist John Wheeler, suggests that the physical universe might emerge from more fundamental informational processes. In this view, the observer effect is not an anomaly or a strange feature of quantum mechanics. Instead, it reveals something essential about the nature of reality itself. Physical properties might not exist as intrinsic features of objects, but rather as relational properties that emerge through informational interactions between systems. An electron doesn't simply have a definite position or momentum. Instead, it has the potential to provide position or momentum information when the appropriate measurements are performed. The act of measurement creates the classical properties we observe by establishing informational relationships between the quantum system and the measurement apparatus. This informational perspective suggests that reality might be fundamentally relational rather than substantial. Things don't exist in isolation with intrinsic properties. Instead, they exist as nodes in a web of potential and actual informational relationships. The observer effect reveals how these relationships crystallize into the definite classical properties that constitute our experienced reality. Consider how this might apply to your own consciousness. Your thoughts, feelings, and perceptions might not exist as things in themselves, but rather as informational patterns that emerge from the complex web of relationships between the quantum systems in your brain, your sensory organs, and the environment around you. This doesn't reduce consciousness to mere information processing, but it does suggest that consciousness might be understood as a sophisticated form of information integration. Your brain doesn't just process classical information like a computer. It may operate as a quantum-informed biological system capable of integrating information across multiple scales and time scales. The observer effect from this perspective is not just about external observation of quantum systems. It's about the ongoing process by which conscious systems, like yourself, participate in the extraction and integration of quantum information from the environment. Every moment of awareness represents a form of information updating process that helps determine what becomes real in your experienced reality. While these ideas might seem abstract and removed from everyday experience, they actually have profound implications for how you might understand your relationship with the world around you. The observer effect suggests that you are not merely a passive recipient of sensory information, but an active participant in determining what aspects of reality become definite in your experience. The quality of attention you bring to different aspects of your environment may influence which informational possibilities become emphasized in your neural processing systems. This doesn't mean you can control reality through positive thinking or wishful intentions. Instead, It suggests that the very act of paying attention participates in the natural, measurement-like processes that are constantly occurring in your brain and sensory systems. Mindfulness practices, from this perspective, might be understood as techniques for refining the quality of information processing in consciousness. When you pay careful attention to your breath, your bodily sensations, or your present moment's experience, you may be refining the processes that determine what becomes conscious and what remains below the threshold of awareness. Meditation traditions have long recognized that the quality of attention affects the quality of experience. The observer effect provides a possible conceptual bridge for understanding why this might be true. Different modes of attention might correspond to different types of information extraction processes, leading to different patterns of conscious experience. This remains highly speculative, and we must be careful not to make claims that go beyond what current science can support. But it does suggest interesting connections between ancient contemplative practices and modern quantum physics. Both recognize the fundamental importance of observation, attention, and the relationship between consciousness and reality. As you go about your daily life, you might experiment with different qualities of attention and notice how they affect your experience. When you look at a tree, for instance, you might alternate between focused analytical attention that extracts detailed information about specific features and a more open, receptive awareness that takes in the tree as a whole. Each mode of observation could correspond to different informational processes occurring in your visual and neural systems. The study of the observer effect continues to evolve as experimental techniques become more sophisticated and theoretical understanding deepens. Researchers are pushing the boundaries of quantum coherence to larger and larger systems, exploring the transition region between quantum and classical behavior with unprecedented precision. Some experiments are beginning to explore whether the observer effect might extend beyond individual particles to more complex systems. Researchers have demonstrated quantum superposition in molecules containing hundreds of atoms, and there are ongoing efforts to create superpositions of even larger objects. The question of where exactly the quantum classical boundary lies remains one of the most active areas of research in modern physics. Other experiments are investigating the role of information more directly. Quantum information theory provides new tools for understanding exactly what happens when measurements are performed and how different types of information extraction affect quantum systems. These studies are revealing the deep connections between information, entropy, and the emergence of classical reality from quantum foundations. Perhaps most intriguingly, some researchers are beginning to investigate whether observer effects might play a role in complex biological systems. While consciousness-based interpretations of quantum mechanics remain controversial, there is growing evidence that certain biological processes might harness quantum effects in sophisticated ways. Photosynthesis in plants appears to use quantum coherence to optimize energy transfer efficiency. Some birds are thought by many researchers to use quantum effects in their sensory systems to navigate using Earth's magnetic field. And while highly speculative, some researchers continue to investigate whether quantum effects in neural systems might play a role in consciousness itself. These investigations don't suggest that consciousness directly controls quantum effects in some magical way. Instead, they explore whether the biological mechanisms underlying consciousness have evolved to operate at the quantum classical boundary in ways that classical physics cannot fully explain. As these research programs develop, they might provide new insights into the fundamental nature of the observer effect and its role in bridging the quantum and classical realms. They might also offer new perspectives on consciousness, free will, and the nature of subjective experience itself. The observer effect raises profound questions about the nature of free will and human agency. If observation plays a fundamental role in determining what becomes real, and if consciousness involves processes related to information extraction, then what does this mean for the choices you make and the control you have over your own experience? Some interpretations suggest that the quantum indeterminacy revealed by the observer effect might provide the physical basis for genuine free will. If the future is not completely determined by the past, if quantum measurements introduce genuine randomness into physical processes, then perhaps there is room for conscious choice to influence the course of events in ways that classical determinism would not allow. However, randomness alone is not sufficient for free will. Random events are not freely chosen events. If consciousness simply introduces random fluctuations into otherwise deterministic processes, this would not constitute meaningful agency. Instead, free will would require some way for conscious intention to influence physical processes in non-random, purposeful ways. This remains one of the most speculative areas of observer effect research. While there is no credible evidence that conscious intention can directly influence quantum measurements in controlled laboratory settings, the question of whether consciousness might play a special role in quantum processes remains open to investigation. Some researchers have proposed that the observer effect might be understood in terms of top-down causation, where higher-level properties of conscious systems influence lower-level processes through mechanisms that classical physics cannot fully describe. Others suggest that consciousness might be understood as an emergent property that arises from information processing but does not directly control physical events. The debate continues, but what seems clear is that the observer effect reveals a universe that is far more open, far more participatory than classical determinism would suggest. Whether or not consciousness plays a direct role in quantum measurement, the fact that observation affects reality means that conscious beings like yourself are not merely passive witnesses to an independent universe. You are active participants in the ongoing process by which possibilities become actualities. This participation might not involve direct mental control over quantum events, but it does involve the ongoing choices you make about where to direct attention, what information to seek, how to interpret your experience, and how to respond to the world around you. In a universe governed by the observer effect, these choices matter in ways that extend beyond their obvious practical consequences. Take a breath and consider how this perspective might influence your approach to daily life. Every choice about where to focus your attention, every decision about what information to seek or avoid, every moment of mindful awareness may be participating in the fundamental quantum processes by which reality is often described as continuously creating itself. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. As we weave together these various threads, a picture begins to emerge of consciousness as a sophisticated form of quantum-inspired information integration. This perspective doesn't require consciousness to directly control quantum events, but it does suggest that the mechanisms underlying conscious experience may operate in ways consistent with natural quantum measurement processes. Your brain processes information from multiple sensory channels, integrates memories with present perceptions, generates predictions about future events, and somehow binds all of this into the unified stream of conscious experience. This binding problem, how separate information processing streams become integrated into coherent conscious experience, remains one of the deepest mysteries in neuroscience. Some researchers have proposed that quantum effects could play a role in solving this binding problem. If different regions of the brain were able, in principle, to become quantum entangled, they might share information in ways that classical neural networks cannot. This quantum information sharing has been suggested as a possible basis for the unity of consciousness that characterizes normal waking experience. This remains highly speculative, and many neuroscientists remain skeptical about the role of quantum effects in brain function. The brain is a warm, wet, noisy environment that would seem to destroy quantum coherence almost instantly. However, biological systems have proven remarkably adept at harnessing quantum effects even in noisy environments, and it's theoretically possible that evolution has found ways to protect and utilize quantum coherence in neural systems. Whether or not quantum effects play a direct role in consciousness, the observer effect reveals that consciousness exists at the intersection between the quantum and classical realms. Your conscious experience emerges from quantum processes in your brain, even if those processes are quickly decohered by environmental interactions. The observer effect suggests that this emergence is not merely passive, but involves measurement-like processes that help determine what becomes conscious and what remains unconscious. Consider your own experience of consciousness as you listen to these ideas. Information flows into your awareness from multiple sources: auditory processing of words and concepts, visual imagery generated by your imagination, emotional responses triggered by certain ideas, memories activated by associations. All of this information somehow becomes integrated into the unified conscious experience of understanding and contemplating these concepts. This integration process may involve natural quantum measurement processes occurring in your neural systems. Not in the sense that you consciously control these processes, but in the sense that consciousness appears to emerge from the complex interplay between quantum information processing and environmental decoherence that occurs throughout your brain every moment. The observer effect doesn't just challenge our understanding of physical reality, it also has profound implications for how we understand meaning, purpose, and significance in human experience. If observation plays a fundamental role in determining what becomes real, then the act of paying attention, of caring about something enough to observe it carefully, becomes a creative and meaningful act. This doesn't mean that you can create reality through wishful thinking, or that subjective preferences determine objective facts. Instead, it suggests that the universe is structured in such a way that conscious observation participates in the ongoing creation of meaning and significance. The aspects of reality that you choose to observe, study, and care about become more definite and significant through the very act of observation. Consider how this applies to human relationships, creative endeavors, and spiritual practices. When you pay careful attention to another person, really listening to what they're saying and observing their emotions and reactions, you're not just gathering information about a pre-existing reality. You're participating in the creation of the relationship itself through the quality of attention you bring to the interaction. When artists, scientists, or contemplatives direct sustained attention toward particular aspects of experience, they're not just discovering what was already there, They're participating in the process by which those aspects of experience become more definite, more significant, more real through the focused application of conscious observation. This perspective suggests that the quality of attention you bring to your life may help shape what becomes real and significant in your experience, not through magical thinking or reality manipulation, but through the natural quantum measurement processes that are thought to be fundamental to how consciousness interacts with reality. The observer effect reveals a universe that responds to attention, that rewards careful observation with increased clarity and definition. This responsiveness doesn't violate scientific objectivity, but it does suggest that the relationship between consciousness and reality is more intimate and participatory than classical physics ever imagined. The observer effect also has profound implications for scientific methodology and our understanding of objective knowledge. Science has traditionally been based on the assumption that reality exists independently of observers, and that careful measurement can reveal objective truths about this independent reality. The observer effect doesn't invalidate scientific knowledge, but it does suggest that the relationship between observers and reality is more complex than this classical picture assumes. Scientific measurements don't simply reveal pre-existing properties of reality. They are part of the process by which those properties become definite through quantum measurement processes. This participatory aspect of scientific observation doesn't make science objective or arbitrary. The predictions of quantum mechanics are among the most precise and well-tested in all of science. But it does suggest that scientific knowledge is fundamentally relational, describing the outcomes of specific types of interactions between conscious observers and quantum systems, rather than absolute properties that exist independent of all observation. This perspective might actually enhance rather than diminish the significance of scientific knowledge. If consciousness and reality are intimately connected through quantum measurement processes, then scientific investigation becomes a form of conscious exploration of the universe's fundamental structure. Scientists are not merely discovering what was already there. They're participating in the ongoing creation of knowledge through careful, disciplined observation. The observer effect suggests that the universe is structured in such a way that it can know itself through the emergence of conscious observers who can perform quantum measurements. In this sense, scientific consciousness can be interpreted as the universe's way of exploring its own possibilities and determining what becomes real through the application of careful attention and measurement. Consider how this might influence your own relationship with learning and understanding. Every time you seek to understand something new, every time you pay careful attention to some aspect of reality, you're not just acquiring information, you're participating in the fundamental quantum processes by which the universe explores and defines itself through conscious observation. As we draw together these various insights, we arrive at a vision of reality that is fundamentally participatory rather than merely objective. The observer effect reveals a universe in which consciousness and reality are not separate entities but aspects of a single, ongoing process of quantum measurement and information integration. This participatory universe doesn't require consciousness to directly control quantum events through mental intention. Instead, it recognizes that consciousness naturally operates through quantum measurement processes, and that these processes play a fundamental role in determining what becomes real at every moment. You're not merely a passive observer of an independent reality. You're an active participant in the ongoing creation of reality through the quantum measurement processes that underlie perception, attention, and conscious awareness. Every moment of conscious experience involves the extraction and integration of quantum information in ways that help determine what becomes definite in your experienced reality. This participation extends beyond individual consciousness to include all the environmental interactions that drive quantum decoherence and create the classical world of everyday experience. The entire universe appears to be engaged in a vast, ongoing process of quantum measurements and information exchange that continuously creates the classical reality we experience. The observer effect reveals that this process is not random or chaotic, but highly structured and organized. The laws of quantum mechanics provide precise mathematical descriptions of how quantum measurements work and what their outcomes will be. But within this mathematical structure, there is room for genuine novelty, creativity, and the emergence of new patterns of organization and meaning. As you contemplate these ideas, notice how they might shift your sense of your own place in the cosmos. You are not an isolated consciousness trapped in a purely material universe. You are an integral part of a cosmic process of quantum information processing that extends from the smallest scales of reality to the largest structures in the universe. The observer effect suggests that consciousness is not an accident or an epiphenomenon, but may be understood as a fundamental feature of a universe that is structured to know and create itself through the emergence of conscious observers. In participating in this cosmic process through your own conscious observations and choices, you are fulfilling one of the universe's deepest purposes: the ongoing exploration and creation of reality through conscious awareness. Perhaps the most profound implication of the observer effect is that it invites us to live more comfortably with uncertainty and ambiguity. The classical world of definite properties and objective facts is revealed to be an approximation that emerges from a deeper quantum reality of possibilities, correlations, and participatory relationships. This doesn't mean that knowledge is impossible or that all perspectives are equally valid. Instead, it suggests that reality is richer, more nuanced, and more responsive to consciousness than our classical intuitions would suggest. Living with this understanding requires a kind of cognitive flexibility that can hold multiple perspectives simultaneously and remain open to the ongoing revelation of new possibilities. The observer effect teaches us that the act of observation is itself creative and participatory. Rather than trying to eliminate the influence of observation to reveal some purely objective reality, we can learn to work skillfully with the participatory nature of consciousness to deepen our understanding and enhance our experience. This might involve cultivating qualities of attention that are both precise and open, focused and receptive. It might involve learning to observe without grasping, to investigate without forcing, to remain curious without demanding certainty. These contemplative skills, developed through practices like meditation and mindful observation, may help support the information processing that underlies conscious experience. The observer effect also invites us to approach life with a sense of wonder and appreciation for mystery. The universe is far stranger, far more participatory, and far more responsive to consciousness than we ever imagined. Rather than being disappointed that we cannot achieve complete objective knowledge, we can be amazed that we live in a reality that is alive with possibility and responsive to conscious awareness. As you continue through your daily life, you might experiment with bringing this sense of participatory awareness to your ordinary experiences. Notice how different qualities of attention affect what you observe and experience. Appreciate the mystery of how your consciousness participates in the ongoing creation of reality through the simple act of awareness itself. Every observation, every moment of conscious attention, every choice about what to notice and what to ignore weaves you deeper into the fabric of a reality that seems to respond to the very presence of conscious observers. In laboratories around the world, a quiet revolution is taking place. Scientists are pushing the boundaries of what constitutes a measurement, exploring the fuzzy borderland between observation and non-observation, with instruments so sensitive they can detect the whisper of a single photon, the flutter of an individual electron, the quantum breath of atoms suspended in perfect isolation. These experiments are revealing that measurement itself exists on a spectrum of intensity and precision. There are strong measurements that completely collapse quantum superpositions, extracting maximum information at the cost of completely destroying the quantum nature of the system. There are weak measurements that barely disturb the quantum state while still extracting subtle information about its properties. And there are protective measurements that aim to extract information about quantum states without collapsing them entirely. Each type of measurement corresponds to a different way that consciousness might interact with quantum reality. The focused beam of analytical attention can be compared to strong measurement processes that extract precise classical information. The gentle awareness of peripheral vision can be likened to weak measurements that gather impressions without destroying quantum coherence. The spacious awareness cultivated in contemplative practices has been speculatively associated with protective measurement approaches. As you reflect on your own experience of attention and awareness, notice how these different qualities of observation feel in your own consciousness. When you focus intently on a specific object, person, or idea, there's a quality of precision and clarity that emerges. Information becomes sharp and definite. Details resolve. But there's also something that might be lost in this focusing process. A sense of the wholeness, the context, the subtle relationships that exist in peripheral awareness. Contrast this with moments of open receptive awareness, where your attention isn't focused on any particular object, but remains spaciously present to whatever arises. In these moments, individual details might be less sharp, but there's often a sense of deeper patterns, subtle connections, and the overall flow and rhythm of experience. This may correspond conceptually to a different type of information processing that preserves coherence and relationship rather than extracting classical details. Some researchers speculate that different meditative practices could train different types of measurement-like processes in consciousness. Concentration practices that develop focused, one-pointed attention may optimize the brain's capacity for precise information extraction. Mindfulness practices that cultivate open, receptive awareness may support gentler forms of information processing. Practices that rest in pure awareness itself have been compared conceptually to regimes where information is accessed with minimal disturbance. This remains highly speculative, and we must be careful not to make claims that go beyond what current science can support. But it does suggest intriguing parallels between the landscape of quantum measurement and the phenomenology of contemplative practice. Both domains recognize that the quality of observation affects what is observed, and both point toward more subtle and sophisticated ways of interacting with the fundamental nature of reality. While consciousness and quantum mechanics make for fascinating speculation, There's growing evidence that life itself has learned to harness quantum effects in remarkably sophisticated ways. This emerging field of quantum biology is revealing that the transition from quantum possibilities to classical realities might not be as sharp or as simple as we once thought. Plants performing photosynthesis appear to use quantum superposition to sample all possible energy transfer pathways simultaneously before settling on the most efficient route. Birds navigating during migration are thought by many researchers to rely on quantum effects in specialized proteins within their eyes to detect Earth's magnetic field. Even the sense of smell has been proposed to involve quantum tunneling effects that allow molecules to be identified by their vibrational signatures rather than just their chemical shapes. These discoveries suggest that evolution has found ways to preserve and utilize quantum coherence, even in the warm, wet, noisy environments of living systems. Rather than being fragile phenomena that exist only in carefully controlled laboratory conditions, quantum effects may be integral to the way life operates at its most fundamental level. Your own body, as you listen to these words, is a quantum mechanical system. The electrons flowing through your neural networks, the photons absorbed by the visual pigments in your eyes, the chemical reactions occurring in every cell, all of these processes operate according to quantum mechanical principles. The classical world of your everyday experience emerges from this underlying quantum substrate through processes that we're only beginning to understand. This doesn't mean that conscious intention directly controls quantum processes in your body. The quantum effects in biological systems appear to be driven by the same environmental decoherence processes that govern all quantum systems. But it does suggest that consciousness emerges from and remains intimately connected to quantum processes in ways that classical neuroscience has yet to fully explain. Consider the remarkable fact that your brain can maintain coherent conscious experience despite being composed of billions of individual neurons, each processing information independently. The binding problem in neuroscience, how separate information processing streams become integrated into unified conscious experience, has prompted hypotheses involving quantum correlations between neural systems. Some researchers have proposed that quantum entanglement between neurons might contribute to the unity of consciousness. Others suggest that quantum coherence in microtubules within neurons has been hypothesized to support sustained patterns of activity associated with conscious states. While these ideas remain controversial and unproven, they point toward the possibility that consciousness might operate at the intersection between quantum and classical physics in ways that classical neuroscience cannot yet fully explain. As you notice your own conscious experience right now, the way different sensations, thoughts, and perceptions seem to flow together into a unified stream of awareness, you might appreciate the profound mystery of how this integration occurs. Whether or not quantum effects play a direct role, consciousness clearly emerges from quantum processes in the brain, and the observer effect suggests that this emergence may involve active quantum measurement processes that help determine what becomes conscious and what remains below the threshold of awareness. The mystery of observation deepens even further when we consider experiments that seem to challenge our most basic assumptions about the flow of time itself. In delayed choice quantum eraser experiments, decisions about how to observe a quantum system appear to be correlated with how that system behaved in the past, even after the system has already interacted with detection equipment. Picture a photon traveling through a complex experimental apparatus designed to test the wave-particle duality. The photon encounters beam, splitters, mirrors, and detection screens that could potentially reveal which path it took through the setup. But here's the twist. The decision about whether to actually extract this path information is delayed until after the photon has already reached the final detection screen. According to our classical intuitions, this delayed decision shouldn't matter. The photon should have already committed to behaving either like a wave or like a particle by the time it reaches the detector. But quantum mechanics tells a different story. The future decision about whether to extract path information is associated with whether the photon exhibited wave-like or particle-like behavior throughout its entire journey through the apparatus. When experimenters choose to erase the path information, making it impossible in principle to determine which route the photon took, interference patterns characteristic of wave behavior appear on the detection screen. When they preserve the path information, the interference disappears and the photon appears to have behaved like a classical particle. The photon behaves consistently with the observational context established by the experimenters. This doesn't violate causality in the sense of allowing information to travel faster than light or enabling communication with the past. The correlations observed in these experiments are consistent with the mathematical structure of quantum mechanics and don't allow for paradoxical causal loops. But they do suggest that the relationship between observation and reality may not conform neatly to our classical notions of temporal sequence. Some interpretations propose that quantum systems exist in a state of temporal superposition, with their past, present, and future behavior remaining undetermined until a complete observation is made. The act of observation doesn't just determine the present state of the system, it contributes to defining the entire temporal context in which that state makes sense. Take a breath and consider what this might mean for your own experience of making choices and observations. The decisions you make about what to pay attention to, what information to seek, what questions to ask, shape not only your future experience, but may influence how past experiences are interpreted and integrated. This remains highly speculative, and most physicists interpret these experiments in terms of correlations rather than backwards in time causation. But they do reveal something profound about the nature of information and observation in quantum mechanics. The observer effect appears to operate not just in the present moment of measurement, but across extended temporal contexts in ways that challenge our classical understanding of cause and effect. As we explore these mysteries, it becomes clear that quantum mechanics is forcing us to reconsider some of the most fundamental concepts in philosophy. What does it mean for something to exist? What is the relationship between mind and matter? How do we distinguish between subjective experience and objective reality? The observer effect suggests that these traditional philosophical categories might be less clear-cut than we once imagined. If observation plays a fundamental role in determining what becomes real, then the sharp distinction between subjective and objective reality begins to blur. The properties we observe may not exist independently of the relationships that make observation possible. This doesn't collapse into pure subjectivism or solipsism. The mathematical structure of quantum mechanics provides precise, testable predictions about what any given observer will experience. But it does suggest that reality might be fundamentally relational rather than substantial. Things might exist not as isolated objects with intrinsic properties, but as nodes in a web of potential and actual relationships. From this perspective, consciousness is not something that exists inside your brain, separate from the external world. Instead, consciousness can be understood as a particular type of relationship between quantum systems, a pattern of information integration and processing that emerges when quantum measurement processes reach sufficient complexity and coherence. Your thoughts, feelings, and perceptions would then be understood not as things that exist in isolation, but as aspects of the ongoing relational process between your neural quantum systems and the quantum environment in which they're embedded. The observer effect reveals how these relationships crystallize into the definite classical experiences that constitute your conscious life. This relational perspective on consciousness has profound implications for how we understand personal identity, free will, and the nature of the self. If consciousness is fundamentally relational, then your sense of being a separate self may be a functional approximation that emerges from deeper patterns of quantum correlation and information exchange. This doesn't eliminate personal responsibility or meaning, but it does suggest that your individual consciousness is more intimately connected to the broader fabric of reality than classical materialism would suggest. The quantum correlations that underlie conscious experience may extend far beyond the boundaries of your physical body, connecting you to the environment, to other conscious beings, and to the cosmos as a whole, through webs of entanglement that transcend classical notions of separation. As you contemplate these possibilities, notice how they might affect your sense of isolation or separation from the world around you. The observer effect suggests that you are not merely an isolated consciousness observing an independent reality from the outside. Instead, you are an integral part of a cosmic process of quantum information processing that includes and transcends individual consciousness. This brings us to perhaps the most profound implication of the observer effect: the recognition that we live in what some philosophers and physicists call a participatory cosmos. This is not a universe of isolated objects interacting mechanically according to predetermined laws. Instead, it's a universe that appears to be fundamentally responsive to the presence of conscious observers and the quality of attention they bring to their experience. This participation doesn't require consciousness to directly control quantum events through mental intention. The universe is not a wishful thinking machine where positive thoughts create positive outcomes. Instead, the participatory nature of reality operates through the natural quantum measurement processes that underlie all observation and awareness. Every moment of conscious attention involves the extraction and integration of quantum information in ways that participate in determining what becomes definite in your experienced reality. This participation occurs through entirely natural processes governed by the precise mathematical laws of quantum mechanics. But within those laws, there appears to be genuine room for novelty, creativity, and the emergence of new patterns of meaning and significance. The quality of attention you bring to different aspects of your experience may help shape what becomes real and significant in your life, not through magical thinking or reality manipulation, but through the natural information processing that occurs when consciousness interacts with quantum systems, according to the principles revealed by the observer effect. This participatory perspective suggests that contemplative practices like meditation, mindful awareness, and conscious attention can be understood as ways of refining how consciousness participates in experience. These practices don't give you control over quantum events, but they might help you develop more skillful ways of engaging with reality through the quality of attention and awareness you bring to your experience. Consider how this might apply to your own spiritual or contemplative practice. When you sit quietly and pay careful attention to your breath, your bodily sensations, or the arising and passing of thoughts and emotions, you're not just observing pre-existing phenomena. You're participating in the processes that determine what aspects of your experience become conscious and how they're integrated into the ongoing stream of awareness. The observer effect suggests that these practices might be more than just techniques for personal development or stress reduction. They may be interpreted as ways of participating more consciously and skillfully in the processes by which experience is shaped through the interaction of consciousness and environment. If consciousness participates in determining what becomes real through quantum measurement processes, then this raises important questions about ethics and responsibility. What are the implications of living in a participatory universe where the quality of attention affects the nature of experienced reality? This doesn't mean that you're responsible for everything that happens in your life through some kind of cosmic law of attraction. The observer effect operates through natural, physical processes, not through metaphysical wish fulfillment. But it does suggest that the choices you make about where to direct attention, what information to seek, and how to interpret your experience may carry consequences beyond their obvious practical effects. In a participatory universe, the quality of consciousness you bring to your interactions with others can influence the quality of those relationships through information exchange. When you listen deeply to someone, paying full attention to their words, emotions, and subtle communications, you're not just gathering information about their mental state. You may be participating in processes that help determine what becomes meaningful in the relational space between you. This doesn't give you control over other people's thoughts or feelings, but it does suggest that the attention you bring to relationships can shape the possibilities that emerge within them. Deep listening, genuine care, and mindful presence might create conditions that allow new possibilities for understanding, connection, and healing to arise naturally. Similarly, the attention you bring to the natural world might affect your relationship with the environment in ways that extend beyond the obvious, practical consequences of your actions. When you observe nature with care and attention, appreciating the intricate patterns and relationships that constitute ecological systems, you might be participating in information processes that enhance your sense of connection and responsibility toward the living world. This participatory perspective doesn't eliminate the need for practical action to address environmental problems or social injustices, but it does suggest that the quality of consciousness you bring to these challenges might be as important as the specific actions you take. Careful attention, genuine care, and mindful awareness might help create the conditions necessary for creative solutions to emerge naturally from the complex web of relationships that constitute social and ecological systems. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. As you consider these possibilities, notice how they might influence your own sense of ethical responsibility. In a participatory universe, every moment of attention becomes an opportunity to contribute to the ongoing creation of experience in ways that support the well-being of yourself, others, and the broader web of life. Recent neuroscientific research is beginning to reveal some of the brain mechanisms that might underlie the contemplative applications of observer effect principles. Studies of experienced meditators show distinct patterns of neural activity that suggest enhanced capacity for sustained attention, metacognitive awareness, and integration of information across different brain regions. These findings don't prove that consciousness directly influences quantum events, but they do reveal that contemplative practices can enhance the brain's information processing capabilities in ways that may support the natural, measurement-like processes underlying conscious experience. Meditation appears to strengthen the neural networks associated with attention regulation, emotional balance, and self-awareness, while reducing the activity patterns associated with mind-wandering, emotional reactivity, and self-referential thinking. From the perspective of quantum information theory, these changes can be interpreted as improvements in the brain's capacity to extract meaningful information while minimizing noise and interference. Contemplative practices may help the nervous system maintain coherent information processing across larger networks and longer time scales. This remains speculative, but it provides a potential bridge between ancient contemplative wisdom and modern science. Both traditions recognize that the quality of observation affects what is observed, and both point toward more refined and skillful ways of participating in the processes that generate conscious experience. As you experiment with different qualities of attention in your own life, you might notice how focused concentration, open awareness, and pure witnessing consciousness each have different effects on your experience. These different modes of observation may correspond conceptually to different types of information processing occurring in your neural systems. Focused concentration might optimize strong measurement processes that extract precise classical information. Open awareness might enhance weak measurement capabilities that preserve coherence while still gathering subtle information. Pure witnessing consciousness has been compared conceptually to regimes where awareness remains present without strongly disturbing the processes it observes. These correspondences remain hypothetical, but they suggest interesting directions for research into the neural mechanisms underlying contemplative experience and their potential relationship to information processing in biological systems. While we've explored the profound mysteries of quantum observation, it's important to appreciate how the classical world of everyday experience emerges from this quantum foundation. The observer effect doesn't mean that classical physics is wrong or that the everyday world is illusory. Instead, it reveals how classical reality emerges as a natural consequence of quantum processes operating at larger scales and longer time scales. Environmental decoherence transforms the superpositions of quantum mechanics into the definite classical properties we observe in everyday objects. But this transformation is not random or chaotic. It's guided by the information structure of quantum systems and their environments in ways that preserve certain types of information while eliminating others. The process is remarkably selective. Quantum decoherence tends to preserve information that is stable under environmental interaction, while eliminating information that is fragile or context-dependent. This natural selection of information creates a hierarchy of stability that extends from quantum to classical scales. At the quantum level, information exists in delicate superpositions that can be easily disturbed by environmental interaction. At intermediate scales, some information becomes protected by collective effects that make it more robust against decoherence. At classical scales, information becomes so stable that it appears permanent and objective, even though it ultimately depends on ongoing quantum processes for its maintenance. Your own experience of reality exists at the intersection of these different scales. Your consciousness emerges from quantum processes in your brain, but it operates primarily through classical neural mechanisms that have been stabilized by evolutionary selection and environmental decoherence. The observer effect reveals how these different levels of reality are connected through the ongoing process of quantum measurement and information extraction. This multi-scale perspective suggests that consciousness itself might be understood as an emergent phenomenon that spans quantum and classical levels of description. Your thoughts and perceptions might involve quantum information processing at the cellular level, while manifesting as classical patterns of neural activity at the systems level. The observer effect doesn't eliminate the classical world, but reveals it as an emergent property of more fundamental quantum processes. This emergence is not a one-time event, but an ongoing process that requires constant maintenance through environmental interaction and quantum measurement. Classical reality is not static but dynamic, continuously created and recreated through the complex interplay of quantum and environmental processes. As we look toward the future, the study of observer effects continues to evolve in directions that might revolutionize our understanding of consciousness, reality, and the relationship between them. Advances in quantum technology are making it possible to create increasingly sophisticated tests of the boundary between quantum and classical behavior. Researchers are developing quantum computers that can maintain coherence across larger numbers of qubits for longer periods of time. These systems provide new laboratories for studying the transition from quantum to classical behavior and the role of measurement in determining which transition occurs. They also offer potential platforms for testing whether consciousness-like information processing might emerge naturally from sufficiently complex quantum systems. Other researchers are investigating whether quantum effects might play a role in biological information processing beyond the examples already discovered in photosynthesis and bird navigation. The possibility that quantum coherence might be important for neural computation, genetic regulation, or cellular metabolism remains an active area of investigation that could transform our understanding of life itself. Perhaps most intriguingly, some researchers are exploring whether the principles revealed by the observer effect might apply to larger-scale phenomena beyond individual quantum systems. Could the same information-theoretic principles that govern quantum measurement also operate in complex adaptive systems like ecosystems, social networks, or economic markets? These investigations remain highly speculative, but they point toward the possibility that the observer effect might be a special case of more general principles governing how information, attention, and awareness interact with complex systems at all scales of reality. The participatory universe revealed by quantum mechanics might extend far beyond the microscopic domain into the realm of everyday experience and collective human behavior. As these research programs develop, they might provide new insights into the nature of consciousness, the origins of meaning and purpose, and the role of awareness in shaping both individual experience and collective reality. The observer effect might turn out to be not just a curious feature of quantum mechanics, but a fundamental aspect of how reality operates at every level of organization. Perhaps the most important lesson of the observer effect is that it invites us to live more comfortably with mystery and uncertainty. The classical world of definite objects with predetermined properties gives way to a more fluid reality of relationships, possibilities, and ongoing creation through conscious observation. This doesn't mean that knowledge is impossible or that all perspectives are equally valid. The mathematical precision of quantum mechanics demonstrates that reality has a deep underlying order, even if that order is more subtle and participatory than classical physics suggested. But it does mean that our relationship with knowledge becomes more humble, more open, and more appreciative of the limits of what can be known with certainty. The observer effect teaches us that reality is not a finished product waiting to be discovered, but an ongoing process in which we are active participants. This participation doesn't give us unlimited control over reality, but it does suggest that the quality of attention we bring to our experience matters in ways that extend beyond their obvious practical consequences. Living with this understanding might involve developing what some contemplative traditions call don't-know mind, a quality of awareness that can remain open to mystery while still engaging skillfully with the practical demands of daily life. This means being curious rather than certain, investigative rather than dogmatic, and appreciative of wonder rather than demanding complete explanation. The observer effect reveals a universe that is alive with possibility, responsive to consciousness, and fundamentally participatory in nature. Rather than being disappointed that we cannot achieve complete objective knowledge, we can be amazed that we live in a reality that is so intimately connected to awareness, attention, and the quality of consciousness we bring to our experience. As you move through your days with this understanding, you might find yourself paying attention differently to the world around you. Each moment of conscious observation becomes an opportunity to participate in the ongoing creation of reality through the quality of awareness you bring to your experience, not through wishful thinking or metaphysical manipulation, but through the natural quantum information processing that underlies all conscious experience. The observer effect ultimately reveals that you are not an isolated consciousness observing an independent universe from the outside. Instead, you are an integral part of an infinite web of quantum correlations, information exchanges, and conscious relationships that includes and transcends individual awareness. Every observation you make creates new correlations between your consciousness and the quantum systems you observe. Every moment of attention weaves you deeper into the fabric of a reality that responds to the presence of conscious observers. Every choice about where to direct awareness participates in the ongoing process by which the universe knows and creates itself through conscious experience. This web of relationships extends across all scales of reality, from the quantum correlations between particles to the information exchanges between neurons, to the conscious connections between people, to the ecological relationships between species, to the gravitational interactions between galaxies. At every level, the observer effect reveals the fundamental interconnectedness of all phenomena through the ongoing process of information exchange and relationship formation. Your consciousness is not separate from this cosmic web, but is one of its most sophisticated expressions, a local concentration of the universe's capacity for self-awareness, self-reflection, and conscious choice. Through your observations, decisions, and moment-to-moment awareness, you participate in the cosmic process by which reality continuously creates and recreates itself. This participation is not a burden or a responsibility in the conventional sense. It's an invitation to recognize your intimate connection to the cosmos and to live with appreciation for the magnificent mystery of which you are an integral part. The observer effect reveals that consciousness and cosmos are not separate entities but aspects of a single, ongoing process of creation through awareness. As we draw near the end of this exploration, take a moment to appreciate the extraordinary fact of your own existence as a conscious observer in a quantum universe. You are a temporary concentration of the cosmos's capacity for self-awareness, a fleeting but precious opportunity for the universe to know and appreciate itself through conscious experience. The observer effect suggests that this opportunity is not accidental but integral to the deepest nature of reality itself. The universe appears to be structured in such a way that it can know itself through the emergence of conscious observers who can perform quantum measurements and extract meaning from the ongoing dance between possibility and actuality. In participating in this cosmic process through your own conscious observations and choices, you fulfill one of the universe's deepest purposes, the ongoing exploration and creation of reality through conscious awareness. Every moment of attention, every choice about what to notice and care about, every instant of conscious presence contributes to the magnificent, mysterious process by which the universe becomes itself. The observer effect doesn't solve all the mysteries of consciousness and reality, but it does reveal that these mysteries are not problems to be solved, but ongoing adventures to be lived. The relationship between mind and matter, between consciousness and cosmos, between observation and reality, remains beautifully open to continued exploration and discovery. As you continue your own exploration of these mysteries in daily life, remember that you are not just learning about the observer effect. You are living it, breathing it, participating in it every moment through the simple but profound act of conscious awareness, in a universe where observation and reality are intimately intertwined. Every moment of consciousness is both a gift and an invitation to participate more fully in the ongoing creation of the world. The observer effect reveals a cosmos that is alive with possibility, responsive to awareness, and fundamentally participatory in nature. And you, as a conscious being capable of observation, attention, and choice, are an integral part of this magnificent, mysterious, ever-unfolding reality. As we venture into our final contemplation, we arrive at something that might seem almost mundane after our journey through quantum mysteries, yet reveals itself as perhaps the most profound puzzle of all: the present moment. This instant you're experiencing right now, as these words reach your awareness. It seems so obvious, so immediate, that we rarely pause to consider its true nature. Yet when we examine the present moment closely, we discover something extraordinary about its relationship to the observer effect and the ongoing creation of reality. What exactly is the present? When does the future become the now, and when does the now slip into the past? If you try to pin down the precise moment of now, it seems to vanish like a quantum particle under observation. The moment you notice it, it has already become memory. The moment you anticipate it, it remains in the future. The present appears to exist only in the eternal act of observing itself. This temporal mystery becomes even more intriguing when we consider it through the lens of quantum mechanics. If observation plays a fundamental role in determining what becomes real, then the present moment might be understood as the temporal location where quantum possibilities crystallize into classical actualities. The now might be where the universe continuously makes the transition from the realm of potential into the realm of experience. Take a breath and notice your own experience of the present moment. There's something immediate and undeniable about this instant of awareness, yet it seems to have no duration, no substance, no fixed location in time. It's always here, yet never quite graspable. It contains your entire experienced reality, yet seems to exist at the vanishing point between past and future. Some interpretations of quantum mechanics suggest that the present moment might be where quantum measurements occur most naturally. The past, in this view, consists of quantum possibilities that have already been collapsed into definite classical states through previous observations. The future contains quantum potentials that have not yet been actualized through measurement. And the present is the temporal boundary where observation transforms possibility into actuality. This perspective suggests that consciousness might naturally operate at this quantum classical boundary, continuously participating in the process by which the future becomes the present through the act of conscious observation. Every moment of awareness might involve quantum measurement processes that determine which of the many possible futures becomes the one actual present that you experience. Consider how this might influence your understanding of time and change in your own life. Rather than being a passive observer of a predetermined timeline, you might be actively participating in the selection of which possible future becomes your experienced present through the ongoing choices about where to direct attention, how to interpret events, and what meaning to extract from the flow of experience. This doesn't give you magical control over external events, but it does suggest that your conscious participation in the present moment might influence which aspects of reality become definite in your experience. The quality of presence you bring to each moment might help determine which of the many possible presents actually manifests in your awareness. As we explore these ideas, it becomes important to consider how the principles we've discovered might manifest in the texture of everyday experience. While quantum effects are most obvious at microscopic scales, their influence extends throughout the natural world in ways that might be far more relevant to daily life than we typically recognize. The morning light streaming through your window right now carried quantum information from the sun across 93 million miles of space before reaching your eyes. The photons that enable you to see these words began their journey as quantum fluctuations in nuclear reactions occurring in the solar core. They traveled through space as quantum waves before being absorbed by quantum receptors in your visual system and converted into the classical neural signals that constitute your visual experience. This quantum heritage doesn't end with perception. The chemical processes that power your thoughts, the molecular mechanisms that regulate your emotions, the cellular activities that maintain your physical health, all operate according to quantum mechanical principles. While these processes are typically decohered into classical behavior by environmental interactions, they remain fundamentally quantum in nature. Some researchers have proposed that life might have evolved sophisticated mechanisms for maintaining quantum coherence in biological systems longer than would be expected in noisy thermal environments. The efficiency of photosynthesis, the precision of genetic replication, the sensitivity of neural processing, all might involve quantum effects that have been optimized by millions of years of evolutionary refinement. This suggests that your daily experience might be far more quantum mechanical than it appears on the surface. The thoughts you're having right now, the emotions you're feeling, the decisions you're making, all emerge from quantum processes that have been shaped by evolution to operate at the boundary between quantum coherence and classical definiteness. While we must be careful not to make unsupported claims about consciousness directly controlling quantum events, this quantum foundation of biological processes suggests that the quality of attention and awareness you bring to your experience might influence how these quantum classical transitions occur in your own neural and physiological systems. Contemplative practices that cultivate refined attention, emotional balance, and present moment awareness might help optimize the natural quantum information processing that occurs in consciousness. Not through mystical intervention, but through the development of more skillful ways of participating in the ongoing quantum measurement processes that underlie all conscious experience. As you move through your day, you might occasionally pause to appreciate this quantum foundation of your experience. The simple act of conscious awareness involves the coordination of countless quantum processes across multiple scales of biological organization. Every moment of consciousness is a remarkable achievement of quantum information integration that deserves wonder and appreciation. One of the most profound applications of observer effect principles might be found in the realm of human relationships. While we must be careful not to make exaggerated claims about consciousness directly influencing external events, there is growing recognition that the quality of attention we bring to our interactions with others can have measurable effects on the quality of those relationships. When you truly listen to someone, paying full attention to their words, emotions, and subtle communications, you're not just passively receiving information, you're actively participating in the creation of a shared informational space where new possibilities for understanding and connection can emerge. The observer effect suggests that this participation might involve more than just psychological processes. In quantum mechanics, observation creates correlations between the observer and the observed system. These correlations persist even after the observation is complete, creating ongoing entanglements that connect previously separate systems. While human relationships obviously don't involve literal quantum entanglement, they might operate through analogous information theoretic principles, where attention creates lasting correlations between conscious systems. The quality of presence you bring to a conversation might influence which aspects of the other person's experience become expressed and which remain hidden. Deep listening, genuine empathy, and mindful attention might create conditions that allow more authentic and meaningful communication to emerge naturally, not through mystical influence, but through the natural information processing that occurs when consciousness systems interact with refined attention and care. Consider your own experience of being truly seen and understood by another person. There's something that happens in those moments that goes beyond the mere exchange of information. A quality of resonance, recognition, and mutual understanding emerges that seems to create new possibilities for both people involved. The observer effect suggests that this emergence might involve sophisticated information processing that operates through mechanisms we're only beginning to understand. This perspective doesn't eliminate the importance of practical communication skills, emotional intelligence, and psychological understanding, but it does suggest that the contemplative qualities of attention, presence, openness, non-judgmental awareness might be more fundamental to healthy relationships than we typically recognize. As you interact with others throughout your day, you might experiment with bringing different qualities of attention to those interactions. Notice how focused listening, open curiosity, and genuine care affect not just what you learn about others, but what possibilities emerge in the relational space between you. The observer effect might extend far beyond physics experiments into the realm of human connection and mutual understanding. The observer effect might also shed light on the mysterious nature of creativity and innovation. Artists, scientists, and inventors throughout history have described experiences where new ideas seem to emerge spontaneously from careful attention to their field of interest. The act of sustained observation often precedes breakthrough insights in ways that suggest something more than mechanical problem solving. When a scientist contemplates a research question with sustained attention, when an artist observes their subject with deep appreciation, when a musician listens carefully to the subtle relationships between sounds, They're not just gathering information about pre-existing phenomena. They might be participating in the quantum information processes that help determine which of the many possible insights actually crystallize into conscious awareness. The creative process often involves a delicate balance between focused attention and open receptivity. Too much analytical focus can inhibit the emergence of novel patterns, while too little attention fails to extract the subtle information that supports genuine insight. The most productive creative states seem to occur at the boundary between concentration and spaciousness, effort and ease, knowing and not knowing. This description resonates remarkably with the quantum measurement regimes we discussed earlier. Strong measurements extract maximum classical information but destroy quantum coherence. Weak measurements preserve coherence while gathering subtle information. Protective measurements somehow access quantum information without disturbing the delicate superpositions that generate it. Creative consciousness might naturally operate across this spectrum of measurement types, sometimes focusing intensely to extract specific details, sometimes remaining openly attentive to preserve the subtle patterns that support breakthrough insights. The observer effect suggests that the quality of attention brought to creative investigation might literally influence which possibilities become actualized in conscious awareness. This remains speculative, but it points toward the possibility that contemplative practices might enhance creative capacity by refining the brain's natural quantum information processing capabilities. Meditation, mindful observation, and other attention training practices might help artists and innovators operate more skillfully at the quantum classical boundary where novel insights emerge. As you engage with your own creative interests, whether artistic, scientific, or practical, you might experiment with different qualities of attention and notice how they affect the creative process. The observer effect suggests that creativity might involve more than just recombining existing knowledge in new ways. It might involve participating in the fundamental quantum processes by which new possibilities emerge from the background of potential into the foreground of conscious awareness. The observer effect might also provide new perspectives on environmental awareness and our relationship with the natural world. While we must be careful not to make exaggerated claims about consciousness directly influencing ecological systems, there is growing recognition that the quality of attention we bring to nature affects both our understanding of ecological relationships and our motivation to protect environmental integrity. When you observe a forest with careful attention, appreciating the intricate relationships between trees, soil, water, air, and countless species of plants and animals, you're not just learning about ecological systems, you're participating in the information processing that determines what aspects of those relationships become conscious and meaningful in your experience. The observer effect suggests that this participation might involve more than just psychological processes. Consciousness appears to operate through quantum information processing mechanisms that create correlations between the observer and the observed system. While these correlations obviously don't give you direct control over ecological processes, they might influence your sense of connection and responsibility toward the natural world in ways that extend beyond obvious practical considerations. Indigenous wisdom traditions have long recognized that the quality of attention and intention brought to interactions with nature affects both the observer and the natural systems being observed. While these traditions don't speak in terms of quantum mechanics, they recognize the fundamentally relational nature of consciousness and environment in ways that resonate with the participatory universe revealed by the observer effect. Modern ecological science is beginning to recognize that human consciousness and natural systems are more intimately connected than classical materialism would suggest. Research on forest ecology reveals communication networks between trees that operate through chemical signals, fungal networks, and other information exchange mechanisms that create collective intelligence across entire ecosystems. Some researchers speculate that human consciousness might be able to interface with these natural information processing systems in ways that involve sophisticated quantum correlations. While this remains highly speculative, it suggests the possibility that contemplative practices in natural settings might enhance both environmental awareness and ecological sensitivity through mechanisms that operate at the intersection of consciousness and nature. As you spend time in natural environments, you might experiment with different qualities of attention and notice how they affect your sense of connection to the living world. The observer effect suggests that mindful observation of nature might involve more than just aesthetic appreciation or scientific understanding. It might involve participating in the fundamental information processing that connects all living systems through webs of relationship that transcend classical notions of separation between consciousness and environment. Another domain where observer effect principles might have profound applications is in the healing arts and therapeutic practices. While we must be extremely careful not to make unsupported medical claims, there is growing scientific interest in how the quality of attention and intention brought to healing relationships might influence therapeutic outcomes through mechanisms that extend beyond conventional psychological and physiological pathways. Research on the placebo effect reveals that the quality of relationship between practitioner and client can have measurable effects on healing outcomes that cannot be explained solely through conventional biochemical mechanisms. The practitioner's genuine care, the client's trust and expectation, and the quality of attention brought to the healing process all appear to influence therapeutic results in ways that suggest sophisticated information processing between conscious systems. Some researchers have proposed that these therapeutic relationships might involve quantum information processing that creates correlations between the consciousness of practitioner and client. While this remains highly speculative and should not be used to make medical claims, it suggests that the observer effect might extend into the realm of healing relationships in ways that complement rather than replace conventional medical understanding. Contemplative traditions have long recognized that the quality of presence brought to healing relationships affects both the healer and the person being healed. This presence is characterized by qualities like compassionate attention, non-judgmental awareness, and genuine care for the well-being of the other person. These contemplative qualities might optimize the natural information processing that occurs between conscious systems during healing interactions. This perspective doesn't replace the need for proper medical training, evidence-based treatments, and rigorous scientific evaluation of therapeutic interventions. But it does suggest that the contemplative dimensions of healing relationships might be more fundamental than is typically recognized in conventional medical practice. As you consider your own experiences with healing, whether as a practitioner or recipient, you might reflect on the role that presence, attention, and genuine care have played in those experiences. The observer effect suggests that these contemplative qualities might influence healing outcomes through sophisticated information processing mechanisms that operate at the intersection of consciousness, physiology and the quantum foundations of biological systems. One of the most intriguing and speculative applications of observer effect principles involves the possibility of collective consciousness phenomena. While individual consciousness clearly emerges from quantum processes in individual brains, some researchers have wondered whether groups of conscious beings might be able to create collective information processing systems that exhibit emergent properties beyond the sum of individual consciousness. This remains highly speculative and controversial, with no clear scientific consensus. However, there have been intriguing reports of collective attention effects in various contexts. Some studies have suggested that when large groups of people engage in coherent meditation practices, there might be measurable effects on social indicators like crime rates, conflict levels, and community well-being in the surrounding area. These findings remain controversial and have not been conclusively replicated, so they should be understood as preliminary and unconfirmed rather than established scientific facts. However, they raise interesting questions about whether the information processing principles revealed by the observer effect might scale up to collective levels in ways that we don't yet understand. If consciousness operates through quantum information processing, and if quantum systems can become entangled and correlated across space, then it's at least theoretically possible that groups of conscious beings might be able to create coherent collective states under certain conditions. This doesn't mean that group meditation can directly control social outcomes, but it might suggest that collective attention and intention can influence the information processing that occurs in social systems through mechanisms that extend beyond obvious practical pathways. Through our gentle exploration of the observer effect, we've discovered something extraordinary about the nature of reality itself. Every moment of conscious awareness, every glance, every choice about where to direct your attention might be participating in the ongoing creation of the universe at its most fundamental level, not through mystical intervention, but through the natural quantum measurement processes that appear to be woven into the very fabric of existence. We've seen how observation transforms quantum possibilities into classical realities, how consciousness operates at the boundary between potential and actuality, and how the simple act of paying attention might be far more profound than we ever imagined. The observer effect reveals a cosmos that is alive with possibility, responsive to awareness, and fundamentally participatory in nature. As you continue through your daily life, remember that you're not merely a spectator in this cosmic drama. Through the quality of attention you bring to each moment, you participate in the magnificent, mysterious process by which the universe knows and creates itself. Every observation is both a gift and an invitation to engage more consciously with the ongoing dance between mind and matter, consciousness and cosmos. The observer effect ultimately shows us that reality is not a fixed stage upon which we perform, but a collaborative creation that emerges through the intimate relationship between consciousness and the quantum realm. And in that realization lies perhaps the deepest mystery of all. If you found this exploration intriguing, you might enjoy discovering how these quantum mysteries connect to an even more fundamental question about the nature of space and time themselves. In Space-Time Fabric Just Shattered, reality is an illusion.